Welcome. Today we're going to talk about pyramids and how to find their surface area. First thing to talk about is what is a pyramid. It's not just a monument in Egypt that usually includes a tomb. We are looking at the geometric pyramids, of course, which are polyhedra with polygon base. So the edges that come up from the corners of that polygon base end up all coming together at a vertex at the top that's called the apex. So this is different from a prism, even though it has a polygon base, because on a prism, those edges that come off of the corners of the polygon base are all parallel. So this one, they're not parallel, they all meet together at one point called the apex. Now a regular pyramid is what we'll be focusing on mostly. A regular pyramid has a regular polygon base, and the apex is directly above the center of the base, which means that the triangular faces of this pyramid will all be congruent. And we'll be able to use that as a shortcut, kind of like we used that shortcut with the rectangular faces in our regular prisms. So our first example, let's find the surface area of this square pyramid. Now, just a little side note, it is called a square pyramid because the base is square. Now, both of our examples that we're working with today in our video are square pyramids, which means finding the area of the base is a little easier than it could be, but there's other tricks that we're going to use. Just keep in mind that as you work through whatever practice problems or anything that you're working on, your pyramid can have a base that's any type of polygon. It could have a triangle base, it could have a pentagon base, a hexagon base, but we've practiced before finding the area of those shapes, of all those polygons, and if you need a refresher on that, here's a link to our area of a polygon video. So our strategy is the same as it was for surface area of prisms. We're going to find the area of each face. Let's go ahead and start with the square base. Now a square is a type of rectangle, so we'll just use the length times width formula that we've been using. And since it's a square, if one of those is 5, the other one's 5 also. So it's really just 5 squared for 25. So our square base is 25 square centimeters. Now let's go ahead and look at one of the triangular faces. Now it is a triangle, so we're going to use 1/2 times base times height. And we've got 5 as our base across the bottom and 8 as our height. So notice the height of the triangle itself, we want to go from the apex at the top and connect to the edge of the base. So right in the middle of our 5 centimeter triangle base, we want to make sure this height actually, our height line that we're measuring actually stays on the triangle that we care about. So we'll plug in these numbers, 5 and 8. 1/2 times 5 times 8 gives us 20. So there's our first triangle face, 20. Since we had a square base that we were working with, that means n equals 4. 4 sides to the square means there are 4 of these triangles that all meet up at that apex. So if we take our 20 from the first triangle and multiply it by 4, 80 is the total for all of our triangle faces put together. Now there's just one more step in finding our total surface area. We just add these two up. So we'll take 25 plus 80 and we get 105 for our total. And of course, we were working with centimeters for our lengths, so our area is in centimeters squared. Not too bad. Let's look at a second example though. We're going to find the surface area of this square pyramid. And you might think, oh, we just did a square pyramid. How is this going to be different? But trust me, you will want to have an example with this type of information given to you. Now we're still finding the area of each face. So we'll start with the square first at the bottom. Now you would, in your own practice problem, substitute in whatever shape your base is, find the formula for area of that shape of base, and go from there. So we have a square, of course, that's an easy one, length times width. 18 times 18 for 324. So there's our square. Now the next up, we need to find the area of our triangle. So we're going to want to use 1/2 times base times height. So pretty much we're the same so far. Our base is 18, but the other number we're given, that 16, is not the height of the triangle that we care about. If you notice this line here, it goes into the center of the base. It doesn't follow that triangular face down the outside of the pyramid. It comes down the middle. This is the height of the actual pyramid, not the height of the triangle that we need. The height of the triangle would have been drawn like this, from the 18-inch base up to the apex. So we're going to have to actually solve for that. And the way we're going to do that is by taking a cross section, essentially, of this pyramid. So let's say we sliced this. We sliced this pyramid open, right down our white line, down the red line. We would end up slicing through the bottom right here where that new white line is. And what we would end up making there, what that cross section would look like, is a triangle. And it's actually a right triangle. You see the right angle there next to the height of the pyramid to the base. This is a right triangle that we've just cut. If we know two sides of the right triangle, we can use Pythagorean theorem to find the third one. Now it looks like we only know one side, but since the height of the pyramid line comes down right in the middle of that square, we know that this length, the bottom of our triangle, is exactly half of the side length of the square, because it's right in the middle. So that means 9 inches here for this part of our triangle. Since the side was 18, we need half of that, so 9. So let's focus on this triangle for a minute. I'm going to bring it out. This is our cross section. It's our same gray triangle with 9 at the bottom, 16 going up the side. And what we need to find then, we're trying to focus on finding this hypotenuse. Because if we find that hypotenuse, then we know the height of our triangle. Since it's a right triangle, let's go ahead and use Pythagorean theorem. A squared plus b squared equals c squared. Now the 16 and the 9 we have are both legs of the triangle. We're trying to find the hypotenuse. So we'll set it up 9 squared plus 16 squared equals c squared. Go ahead and use your calculator to solve that out unless you just know those both off the top of your head. We'll add them up for 337, and then remember we take the square root of both sides to get back to regular c, which would be 18.36. So that 18.36 is our hypotenuse. But remember, the hypotenuse and the way this all fit in our pyramid originally, that hypotenuse fills in here for that actual height of the triangle. So now that we have that, let's refocus. Forget the cross section. We found the number we needed. Let's focus back on the triangle face that we were trying to find earlier. So 18 at the bottom, that's our base. And we just solved for the 18.36, that's our height. So we can go ahead and fill in those numbers now. Once we multiply those all together, we get 165.2. So that is the area of one of our triangular faces. Now, since we're working with a square base has 4 sides, so we have 4 of these triangles. So we'll take our 165.2 and multiply it by 4. That means the total for our triangle faces, all 4 of them together, is 660.8. So now to find our total, we just add those up. And our total surface area is 984.8 square inches. Final answer. So just remember, with these pyramids, you're still finding the area of each flat surface and adding them all together. Just like we were doing with the prisms, you just find the area of each flat surface. The one thing to watch out for is make sure you know the difference and if the numbers you're being given are pyramid height or if they are triangle height. Because to find your surface area, you need the triangle height. We'll use pyramid height in the future, but we're not using it yet. So make sure that you either are given triangle height or you have solved for the actual triangle height. But that's all I have for surface area of our pyramids. So thank you for joining me, and I will see you next time.